The effects of substrate materials on subsequent growth in Raphanus sativus L. microgreen harvest. Written by Stephen Jameson with Professor Jim Myers. Microgreens are the seedling shoots that are picked just after the first leaves of the plant have developed. Studies suggest that microgreens may contain high concentrations of nutrients compared with mature vegetables and herbs. Due to their high antioxidant content, microgreens are considered a functional food, a food that promotes health and prevents disease. The microgreen variety of North American Raphanus sativus L has been found to contain significant amounts of glucosinolate, a well-known anti-carcinogenic, which are an excellent source of folate and is believed to promote cardiovascular health. In our experiment, an assessment of differing substrates used for the growth of Raphanus sativus L microgreens will be performed during the initial 24-hour soaking phase of the single jar growth method. The purpose of this experiment will be to find if ranging growth changes in actual weight of harvest could be amplified by variables in the initial cleaning and soaking of the seeds. Several different substrates are going to be used during this experiment, including purified water, salt water, marketed plant growth hormone, and filtered animal fecal extract, and one containing no substrate at all. In the traditional method of single jar growth of microgreens, the seeds are soaked for a 24-hour period in clean water. Although this step is not mandatory in the growth of microgreens, it is considered common knowledge that certain varieties of microgreens will sprout easier when the hard shell that surrounds the seed has been softened with moisture. This will also allow for a quicker germination time and more even growth of the stems and first leaves. It's within this time frame period that the variables of this experiment will take place. While the pre-soaking stage helps with germination and other growth factors, the question of this research is if the substrate used during the time is an actual opportunity for the seeds to also soak in essential nutrients that will affect the actual harvest weight. By using known methods of pre-soaking, such as purified water, and comparing those harvest weights with the known method of using no substrate, we'll then have the ability to compare and contrast the harvest weight of the other three unknown effects of substrates. Our hypothesis for this experiment is differing substrates of the pre-soak process of microgreen growth can have a direct effect concerning the total post-harvest weight. The experimental substrates that will be used are as follows. Purified water. Since the normal single jar growth method uses normal water as the substrate in the widely known technique, we will be conducting our experiment with this as our control group. No substrate. The first variable use of substrate will be conducted using no pre-wash at all. From previously viewed experiments, the 24-hour pre-wash stage can be completely omitted depending on the seed type. It's my belief that Raphanus sativus L needs this stage to properly initiate germination. Therefore, I hypothesize that the omission of this process will cause the seeds to not sprout, leaving the post-harvest weight at 0. Salt water. Several experiments have been done over salinity content of microgreens in the use of salt water as a pre-soaking method. Some of the experiments have shown stunted growth patterns, but the results were inconclusive within the relative research. It is believed that within the confines of this experiment, we will have a slightly lower post-harvest yield than with the control group. Miracle-Gro Performance Organics all-purpose plant nutrition granules. This very well-known plant growth enhancement product has been used around the world and has shown to be effective in producing higher yields of garden vegetables. It's my belief that this will be the highest performing substrate and will produce a post-harvest weight of no less than 1.35 that of our control group. Our final experimental substrate will be organic llama liquid fertilizer. This is found locally made with llama fecal matter. The product boasts to be 100% non-GMO and is highly praised by Colorado herb growers that increase product yield. Due to the non-scientific nature of this product, yet also regarding this high praise from local growers, I believe that this will increase the post-harvest yield of this experiment by 1.2. The use of microgreens as part of a nutritious diet was popularized in the late 1970s. Since then, there have been a plethora of scholarly articles published on the subject. While the nutritional values and various growth processes have been studied in detail, there aren't very many published articles that are specifically related to the short time frame and specific process involved with this particular experiment. The article entitled Seed Treatments to Advance Greenhouse Establishment of Beet and Chard Microgreens detailed germination percentage changes with very little results. This experiment concentrated on the use of hydrogen peroxide, hydrogen chloride, and sodium hypochlorite. While these chemicals are excellent in the use of sterilization, it would do very little for our goals of obvious harvest weight changes. Another similar article published in the International Journal of Biological Macromolecules entitled Effect of Salinity Stress on Bioactive Compounds and Antioxidant Activity of Wheat Microgreens Extract Under Organic Cultivation Conditions concentrated on differing salt content for this pre-soaking phase of growth. Not surprisingly, this resulted in a higher salt content of the actual microgreen harvest. This particular article gives me great confidence in my hypothesis that the seeds will indeed be able to soak in the nutrients of a given substrate during the phase of growth, resulting in a change of the post-harvest weight. The results of this experiment will be strictly quantitative in nature and should consist of the ending full harvest weight after 7 days of growth. This experiment will be conducted in 4 different times, and the results will be the mean of corresponding harvests. The process of gaining these weights will be: measure out 1 tablespoon of Raphanus sativus seeds 3 times. Then place each measurement of these seeds into separate containers of each substrate under experimentation, 2 inches in depth. The seeds will then soak in these substrates for 24 hours. We'll then drain and dry the seeds, sanitize 5 containers that will be used. These will consist of 16-ounce ball mason airtight canning jars. We'll then add the saturated seeds to each jar. Place the jars in a temperature-controlled space that is out of direct sunlight and continue tracking the weight and growth rate of each jar every 12 hours for the 7 days. After the full 7 days of growth, we'll harvest all microgreens from each jar, individually clean and weigh each envelope of microgreens. These steps will then be repeated 4 additional times for any changes in experimental factors. A major limitation of this experiment will be in the results that are based specifically on the post-harvest weight of the product. There's many other factors that are involved with gaining insights in using different substrates. These can range from specific vitamin content to total nutritional value or a lack thereof. We will specifically be dealing with post-harvest weight. Microgreens have the potential to affect world food populations on a mass scale. They're easy to grow, extremely healthy, and highly transportable. This pre-soak stage experimentation could be vital for processes used in the future pertaining to emergency health crises around the world. Properly pre-soaked seeds could be growing in transport and arriving as ready-to-eat nutritional meals. The commercial value of these results could affect world economies. There are also factors that could be implemented in space studies to help secure dietary needs for off-world colonies and space exploration.